Kia ora. This is an introductory video to the acids and bases topic for Year 10 Science. In this video, we will look at acids and bases, distinguishing between alkali and bases, and compare and contrast acids and bases. All right, so you've probably heard or seen some acids and bases around your home before. Vinegar, lemons, okay, those are types of acids, whereas bases, we've got baking soda and ammonia. So some of the properties for acids and bases are on the screen. We've got acids, usually taste sour. Acids react with some metals to give off hydrogen gas, so they bubble. And we have conduct electricity in solution. Whereas bases usually taste bitter, they feel slippery like soap, and they dissolve fats and oils like dishwashing liquid. Down the bottom, we have a scale. Now, don't worry too much yet about what these numbers are representing, but basically, acids and bases can be found anywhere on this pH scale. Basically shows you how acidic or how basic solutions are. Household cleaner is actually quite highly basic, whereas lemons are acidic, whereas milk is right in the middle, so it's neutral. It's not acidic or basic. So acids are compounds which contain hydrogen. All acids have the letter H in their formula, which means they contain the hydrogen H. Hydrochloric acid is HCl. It's found in the lab in the stomach. Sulfuric acid, H2SO4, is found in car batteries. Nitric acid, HNO3, is found in fertilizer. So we can see all of these acids contain the hydrogen atom. Acids usually release hydrogen ions. Now, hydrogen ions, this is basically what it looks like. H, which is hydrogen, and it's got a charge, a plus. Okay, let's now look at bases. So a base is a chemical opposite of an acid. A base is a metal oxide or metal hydroxide, or a metal carbonate. Here are some examples. Sodium hydroxide, NaOH. Calcium hydroxide, CaOH2. Okay, so that's the hydroxide group, which is OH. Sodium carbonate, CaCO3, that is a carbonate group, as we can see. And then sodium bicarbonate, baking soda, known as NaHCO3, sodium hydrogen carbonate. Okay, so just to recap what these the chemical symbols are, I will just draw them on the screen for us to look at that. Okay, so OH is hydroxide. CO3 is carbonate, and HCO3 is known as hydrogen carbonate. Okay. So let's now look at the next bit of information. So a base reacts with acids and it neutralizes the acid to make salt and water. Now we will look at neutralization later. Base releases hydroxide ions when dissolved in water. They're generally metal oxides, metal hydroxides, metal carbonates, and metal hydrogen carbonates, as we have just said before. Now, bases that dissolve in water, we call them alkalis. All alkalis are bases, but only soluble bases are alkalis. Okay, so soluble bases are alkalis. Okay, soluble basically means it can dissolve in water quite easily. Okay, so you can do some research if you want, just look at some bases, some examples online. So some more facts about bases. Bases react with oil and grease to form soap, hence soap feels soapy and slippery as they react with the oils on your hand. They're generally found in cleaners, toothpaste, indigestion tablets. All of these are examples of bases. Okay, so just to recap again, the difference between an alkali and a base. Bases do not dissolve in water, but alkalis do dissolve in water. They are soluble in water. Okay, so if we add acids to water, this is basically what would happen. So hydrochloric acid is the example here. We find it in the laboratory or in our stomach. Okay, hydrochloric acid has the chemical formula of HCl, which means it contains hydrogen and chloride. Okay, hydrogen chloride. So basically, if we add hydrochloric acid to water, we can see that the hydrogen ions and the chloride ions separate. Strong acids have hydrogen ions and they separate in water. When the hydrochloric acid is added to water, the hydrogen and chloride ions dissociate or split apart. Now this is a key word which you do need to know, dissociate, which means split apart. The free hydrogen will then combine to form water. Okay. So hydrogen will combine to form, with water to form formic acid, citric acid, sulfuric acid, and acetic acid. Okay, this is just some examples. Okay, so this is the last slide for this video, and it's going to basically look at concentrated versus dilute. Now, this is a really important concept, and usually you can think of examples in everyday life. You may think of if you're making a Raro drink, for example, having a concentrated Raro drink, or Milo, for example. Concentrated means you have lots of Milo and not much milk. Okay, whereas dilute means you've only got a little bit of Milo or Raro in a given volume of milk or water. Okay, so the definition for concentrated means that there are more particles of hydrogen or hydroxide in a given volume of solvent, whereas dilute means there are less particles in a given volume of solvent. Now, if we look at the picture down below, we can see that the volume of solvent is exactly the same in both of these beakers. Okay, so this one has, for example, 100 mils of water, and this beaker also has 100 mils of water. It is the given volume of solvent. Now the solvent itself is the water. Okay, just to make that clear. So we can see with the left diagram, the concentrated solution, we have lots of these particles. Okay, just imagine each one of these was a hydrogen, heaps of those in 100 mils of water, and this one we've only got a few of the hydrogen ions in this much water. All right, that is the end of the first video.